All right, welcome to the course on sustainable systems design. This course is about life cycle analysis, footprint methods and industrial ecology. And I'm Dr. Shweta Singh. I'm an associate professor in ag and bioengineering and environmental and ecological engineering with a joint appointment with Davidson School of Chemical Engineering at Purdue University. So today we'll get started with the introductory lecture that will introduce you to the concept of sustainability science and the three pillars of sustainability that we integrate in our analysis, and then we'll get into the first equation that combines the three pillars of sustainability. So moving on to the introductory slide, our lecture outline today is we'll first go to the introduction to the field of sustainability science, where it originated from, what is the definition of sustainability, and how do we interpret sustainability when we think about in terms of analysis and design. Next, we will go to the different paradigms for sustainability. So when we think about sustainability, there are three different pillars that we think about. One is the economic, then ecological and social. So we will talk about the evolution of three different paradigms that are used in sustainability science. And the last, we will look at the first attempt that has happened to combine these pillars of sustainability into one equations, and then what are the limitations of this equation that will lead us into the holistic system science for analysis and design of sustainable systems. So what is sustainability science? It is a new field that has been emerging that seeks to understand our interactions with nature and society. So as engineers, we have been designing technical systems that achieve a certain production goal or that achieve a certain task, such as in robotic system. But in sustainability science, we are also concerned with our interactions with environment and society, so that the systems that we design are moving along into sustainable trajectories. This definition I have taken from this article on sustainability science by Cates et al. In the journal 2001. When we think about the current field or the current state of the field, what we are focusing on, or the scientists have been focusing on, is developing a stronger analytical and scientific underpinning by bringing together knowledge between several fields together, which includes natural systems, engineering, social science, even medicine, economics and politics. In this course, we will be focusing a lot more on engineering and economics, not that much on social science, medicine and politics. However, sustainability science is inherently a very interdisciplinary field that requires a lot of different fields merging together to solve this very complex topic of designing sustainable systems. Going back to the definitions, the first definition that came on, and the task is of course to understand what does sustainability really mean. When the Brundtland Commission met in 1987, they posed this definition, which was development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So when we think about this definition, there is this inherent temporal and spatial dimensions to think about the problem solving. So we are not only as engineers thinking about meeting the demands of today, but also ensuring that the demands of future are also met. As any engineer would know, when we design our system, we are always thinking about prediction and design and controllability. This is exactly what sustainability science is talking about, that when we are trying to meet the demands of today's society, we should not undermine what the demands of future would be. And that makes it a very complex challenge because the demands evolve. We are also thinking about the capability of the Earth's ecosystem that helps to sustain these demands. Hence, when we think about the three pillars of sustainability, we certainly have the economy in the picture, which is really important because that determines how the demand is going to change. Then we have ecology, which is the underpinning system that provides the natural resources, and hence we also need to account in what is the ecological dimensions of the system that we are designing, and how can we meet the demand for the future generation as well. And then the last is society. As we know, society is a really complex system. It keeps changing, the demands change, and also how we respond to different changes. So there is this complexity and complex interaction of different aspects that needs to be accounted when we talk about sustainability. So let's get into the economic paradigm, and here I will present a picture of how the economic paradigm evolved, as that was the first paradigm that people started thinking about when they started thinking about sustainability. So in 1798, it goes long back, Robert Malthus wrote an essay on the principle of population. So as the society evolved, as the population grew, we really started thinking about how can we sustain the growth in population without leading to poverty, because the resource distribution was not equitable. That led to an idea that this expansion and the growth that is not well managed can lead to poverty, and that probably is not sustainable. But that came from the economic paradigm, because we are talking about money here. We are talking about the quality of life that is directly led by the economic status. Then in 1865, Jevons talked about the finite supplies of coal. As industrial revolution happened and we started relying on the coal, it became pretty evident very early on that these resources are finite and we cannot keep on consuming them indefinitely. So Jevons highlighted about the Britain's energy consumption in his book, talking about the coal question, and it was about inquiry concerning that can the nation progress at the speed that it was at that time with the limited resources they had in terms of coal mines. And as we all know, energy is a very important aspect of growth and continuous of the growth. So this essay highlighted how limited energy resources were really an important aspect of economic sustainability. Then in 1952, in United States, the President Materials Policy Commission was formed that was talking about the post-war economic sustainability, and there was a lot of consumption of non-renewable minerals, including metals, and that highlighted that the economic growth that was happening at a very expediting speed after war was not sustainable. So all of these development over years, where different scientists and philosophers, they came together to think about the economic paradigm of sustainability, highlighted that in terms of economic growth, we really need to think about, is this growth going to be sustainable? The final essay came from Meadows in 1972, which is the limits to growth. And this is where the economists started really thinking about the growth paradigm and whether it is sustainable or not. So these examples, these early evolutions give an idea of that economic growth is not always sustainable, and we need to think about whether the way economy is going is actually sustainable or not in terms of designing the systems. The next, I will talk about the ecological paradigm, and this is another very important aspect of growth and sustainability. As we all know that environment is changing, and we also know the decline in lot of environmental reserves. This was something that came into picture when lot of fisheries and lot of streams were declining. So the first thing that goes in ecology is the dynamic nature of the ecological systems, and a lot of these biological systems remain diverse and productive. As we all know that Earth is millions of years old, so it is very imperative that there is an inherent sustainable aspect of these ecological systems. However, when the UN Convention of Biological Diversity met, they estimated that there are about 13 million species, and we are still discovering new species in this paradigm. However, in about 2010, they estimated that 803 species have gone extinct and about 11,000 are threatened for extinction. So the IUCN is maintaining a red list which highlights what are the different species on Earth that are going extinct. Of course, that leads to a question, are all species sustainable? We have the historical evidence of different species on Earth that have gone extinct during different meteor attacks on the Earth system. But the main question when the sustainability scientists think is that why are the species being extinct? So of course there's climate change, which is not only a threat to animal species but also human beings. There is a lot of life loss that happens because there is climate change that leads to tornadoes and earthquakes and other kind of geophysical phenomena. Land expansion by human population has been known to affect the wildlife. So there is an inherent conflict between human urban expansion and the maintenance of ecological diversity. The last, which we talk very often, is about pollution. Pollution has affected human health. So definitely the ecological paradigm of sustaining human health itself is necessary to think about the design of sustainable systems. Next, we also talk about geographical changes. So this is something that is very important because if we want to maintain the reserves that support our economic systems, we need to think about preserving rivers, streams and natural wetlands. The wetland losses and the nature conservation is something that is at a very high priority in different nations of the world because they provide essential services to human beings, which cannot be designed without the presence of these natural systems. Flora and fauna are also native ecosystems. They provide certain ecosystem services that are not that are threatened when we do not take into account of these ecological systems as part of our designed systems. So this gives us an overview of when we think about sustainability, how ecological paradigm can be brought into our thinking to design our systems, which very often as engineers we ignore because we do not know how to connect these aspects into our design problems. The last one is the social paradigm. So this one is the one which is very difficult to incorporate because we do not really think about designing a society. So when we think about the decline of civilizations, there have been really advanced civilizations in the past like Western Roman Empire. One that is very close to India is the Harappan Indus Valley civilization, and a lot of these civilizations had advanced technology as well, and still these civilizations have gone extinct. So when you think about the collapse, mostly the collapse has been reasoned because of the climate impact, environmental degradation or mismanagement of resources that weakened these empires and leading to successful invasions or internal conflict that led to war and also the decline of the civilizations. So when we talk about the decline of society or social sustainability, we can think of a recent decline of Soviet Union. So that goes into more into human behavior or the political aspect of it, which I will not discuss a lot in this course, because we are more going to focus on the engineering and economics part of sustainability. However, when you think about sustainability, the way engineered systems interact with society and affect the societal evolution is an important aspect of sustainable systems design. A recent example is the evolution of AI and the AI based tool, which is very fast changing the way society interacts and the way society responds to changes. And once, as engineers, when we are designing these systems and we think about sustainability, we should certainly think about how do these emerging technologies affect the society and rise or decline of our societal systems. In summary, when we think about sustainability, we have the three spheres of sustainability. One is the social and the environmental, which is the same as ecological, and the economic. And this is a Venn diagram that shows the interaction. So when we think about the environmental, we have the natural resources, environmental management, pollution prevention, which goes mostly in maintaining our ecosystems that provide the resources to sustain our economic and social systems. When we think about the economic system, these are mostly driven by profit, cost savings, economic growth, and also sustaining the demands that are providing the demands that are in the society for maintaining the growth that is projected by different nations. And the third one is the social, and in social we mostly focus on the standard of living, education, community, peace, stability, and equal opportunity. When we think about the interactions of environmental and economic, we talk about energy efficiency, that is at core of as engineers when we design our systems, because we are not only thinking about economic profitability of the system but also its environmental impact. When we think about the environmental and social interaction, that is where we talk about environmental justice, natural resources stewardship, and local and global maintenance of those systems. So this is where we talk about how societies and the local communities are getting affected by environmental degradation, and how can we maintain the sustainability of environmental and social interaction systems. And then we have the economic and social. This is where a lot of businesses need to come forward, talking about business ethics, fair trade, and workers' right in terms of providing equal opportunity, but also maintaining the profit that the economic systems need for its own sustainable design. And then at the interaction at the center, where all three environmental, economic, social systems interact, that is where we will achieve true sustainable systems design, which is a very complex and difficult task. And in this course, we will mostly be talking about how we are thinking about solving some of the economic and environmental interactive systems. We will not focus on the social, but the systems view that we develop can certainly be expanded to the social sustainability paradigm. With that, we will go into our first thought activity, and we all know examples of pollution in the river. So I would encourage you all to take 30 seconds to think about the three pillars of sustainability and how the three pillars of sustainability are affected by a polluted river. So for this activity, I will leave this sphere in front of you, and I would encourage you to think about this problem and mention the challenges that are posed by a polluted river in environmental sustainability, economic sustainability, and social sustainability. So let's think about which pillar of sustainability is affected by a polluted river. The first one is obviously ecological, because rivers are an ecological entity. So what happens because of polluted rivers is it disrupts the ecological life within aquatic ecosystems. We see decline of fisheries, we see the decline in biodiversity of the fishery system, and that is what the direct impact of river pollution is on our ecological sustainability. The next is economy, of course, because when the fisheries are declining, the fish production is also declining. That leads to the lower production of fish, which is a contribution to the economy in terms of food production. It affects the livelihood of local fishermen who are living along the coast, and that leads to declined economic productivity in that region. We also have high cost of water treatment because we take a lot of water from the river that goes for treatment, that comes to our household. So, we have a very high cost of water treatment that gets translated into high public cost of acquiring water. So, water utilities get impacted, and that is the economic impact of polluted rivers. There is also diseases. When we have polluted rivers, we might have some chemical pollutants that comes directly into our drinking water, and that leads to diseases, which leads to rising cost of healthcare. And we do not, of course, directly see this impact, so we call it as the indirect impact of polluted river on the economic sustainability. The last is the social impact. Of course, when there is a polluted river, we do not want to go close to that river. So, we have lack of recreational activities. If we can clean our river system, we will connect with nature more. We can also go and connect with our local communities more. And there is also lack of knowledge of river because we really do not want to interact with that system that much. So, this is the social impact of sustainability, social sustainability impact of a polluted river, and this again is an indirect impact. What I want you to highlight is that the direct impact of pollution is something that is very easy to know. We really think a lot about how we are disrupting the fisheries, but we do not really see how it is affecting the economy and the social sustainability because of the indirect links of this pollution to economic food production, but also to the social systems. Hence, when we look at any problem and we use these three different pillars of sustainability, it helps us to identify both the direct and indirect linkages of taking into account of what the sustainability challenges we can face in these problems. So, now what we will do is we will move ahead into combining these three pillars into the first equation that helps us calculate the impact of these three different sustainability challenges into one equation. So, the first equation that tried to combine these three pillars of sustainability is called the IPAT equation. So, what the IPAT equation did was it brought the attention to the fact that technology and society interact to result into environmental degradation or preservation based on the nature of technology. And when we are trying to solve an environmental challenge, we should target the impact both on the technological and societal and economic aspect. So, if you are really interested, I would encourage you to read this general reading on impact of population growth that talks about how these three different pillars interact. So, what is the IPAT equation? IPAT equation has three different components. So, we have impact. So, I is for impact. The second one is P multiplied by A and multiplied by T. So, P is related to population, and when we think about population, that is actually the societal pillar of sustainability. A is related to affluence, and when you think about affluence, it is related to economic and society both, and the last one is the technology. So, when we think about technology, technology is related to both economic and the environmental aspect. And the reason I say technology is related to both environmental and economic aspect is because as the economies change, the technologies are changing, but also it affects the environment. So, the first component of our IPAT equation is population, and in most general terms, globally the population is increasing. The second one is affluence, and the affluence is basically talking about how we are increasing our consumption per capita. So, the consumption per capita is mainly how much are we consuming per person in any region. It can be a country, it can be a local region. It is definitely increasing more rapidly in developing economies, and developed economies like Western economies already have very high per capita consumption. And then the last one is technology, where we are seeing the interaction of technology and environment. It's pollution per unit consumption. So, overall, because of the rise in the awareness, we are implementing cleaner technologies, and this aspect or the technology pollution per consumption is decreasing because of the improvement in efficiency, such as in energy resources, but also in the production technologies. So, as engineers, we generally see this third aspect of pollution per consumption because we are able to design more efficient energy systems, we are able to design more efficient production systems, but also we are able to design recycling technologies and other important technologies. So, if we do really have a direct control on the third aspect, which is the technology aspect of it, but when we talk about the other two parts that are impacting the sustainability of the whole global system, we really do not have much impact. So, population and affluence is something that is obviously going to grow. So, it is a dynamic interaction. How fast are we going to change the technology that can reduce the impact overall versus the increasing per capita consumption and increasing population. So, this IPAT equation really helps us combine all the three pillars and makes us realize that maybe we are not doing enough in terms of technology to actually reduce our overall impact, because there are other aspects such as population and affluence that are also affecting the impact on sustainable design. So, what we will do, I will give you a simple problem with some data and you will apply this equation to see how the impact is changing and what is the actual reduction in the technology in terms of pollution per consumption versus what is the total reduction in the impact. So, here is the problem. So, once we solve the problem, you will see that the actual reduction in the total impact was much lesser than the total reduction through the technology. So, IPAT equation showed us that, so we saw that actual reduction in impact So, what the IPAT equation showed that because we have different aspects that are contributing to the total impact, we have a very high reduction from the technology perspective, which is pollution per unit consumption, but because of the increase in the consumption because of the affluence and the, let us say, increase in the population itself, we saw that we had much lower reduction in actual impact. So sometimes what we do in one part of the sustainable design does not lead directly into the overall reduction, and this has to be accounted when we are thinking about overall sustainable design, because we cannot just change one lever and expect it to directly translate into the overall system. So of course, the strength and limitations of IPAT is that we are able to see different aspects together, that is the strength, and limitations is that it does not really help us see the translation into actual real systems directly. So we saw that technology development led to reduction in the pollution per consumption, but our overall impact was not that much less. So what happens is that as engineers, when we are developing technology, we are designing, we actually fail to see how these technologies are interacting in the overall societal system or in the overall economic system. So there are two aspects that led to the failure of a design of sustainable technology, but translating it into actual sustainable design. And the two reasons are, first is externality, and the externality means that it is an aspect that is affecting the sustainability of the system, but it is not incorporated into the design. And one of that aspect is that how do markets function, or how does this particular one system, let's say one car that you designed, and how does it interact with the overall infrastructure that is an ecosystem surrounding use of that technology. And then the second one is reductionist versus holistic view, and that means that if you are changing a technology or if you are developing a technical systems, how do decisions about the use of that technology changes, or how do the decisions surrounding the ecosystems that support that particular technology changes. So what we will do is we will look into what does externality mean and what is the reductionist versus holistic view that leads to changes in one part not translating into actual impact into the overall system. So when we think about the market behavior, what enables the market to work? There are four things. One is of course price or value setting. Second is profit motive, private property, and government and other regulating institutions. Whenever we are designing a technology and we think about its interaction with market, these are different aspects that will determine how that technology is behaving in the market. So of course, when you are making a system, you have this value setting, you want to operate it at a certain cost, and if you are working for a company, you have a profit motive that this technology needs to make a certain amount of profit. Whether it's a private or a governmental property, it will have different institutions and it has different rules and regulations. So the way a technology behaves in the overall ecosystem will actually determine whether the benefits that you are seeing in terms of its environmental sustainability are translating into real systems or not. So what happens is that lot of time these human necessities often fail in markets. So lot of time mostly the markets are mostly focused on production and profits. There is not an actual cost that we can talk about cleaning air or water. We cannot talk about damaging your air quality. So for example, we see every year stubble burning and there is air quality loss. But the systems are not talking about whether that privatization of profit, where we are burning the waste, is actually translating into air quality and health issues for all the citizens surrounding that region. No one is willing to pay for clean air, so there is no cost we can put on cleaning air. And should you have to pay for clean air? So this is something that comes into more of the social sustainability aspect, that society perhaps is we have the right to live in clean air. So putting a cost on environmental degradation is not generally accounted for in technological economic evaluation when we are thinking about the technological sustainability only. So the field that looks into this is ecological economics. We talk about How can we incorporate the economics into the aspect of environmental degradation that can be taken to the technology development, so that that becomes a part of evaluation when you are designing a technology. So that way you will not miss that market behavior aspect into design of your sustainable technology. Similarly, we cannot of course talk about clean air as a private property. We cannot talk about the price setting for the air. We cannot talk about what was the air quality of the air that we bought. And there is also not any rules and regulations that can put into account that if you are making an air dirty, you have to pay. Of course, there are now tax and there are environmental regulations that are brought into the picture, but that does not get accounted into systems design itself. So, when we think about these externalities, there is a term for it in economics which is known as tragedy of commons. And the meaning of tragedy of commons is that we have, when we are making something or when we are producing things using our technology or when we are driving a car, we have an unintended cost or benefit of that production or consumption that is not reflected in the price of the related transactions, which means that let's say I am a consumer and I am consuming a certain product, but because of that consumption I am making the environment more dirty, but the price of that consumption does not reflect that into the aspect of me consuming that product. So, this is an externality which is a negative unintended cost to the society that is not accounted for in me consuming that product. So, as engineers, when we are developing, when we are let's say designing a manufacturing plant, we might be damaging the local soil quality, but that local soil quality is a publicized unintended cost to the society that is not accounted in the pricing of setting up that plant. So, this is what we call as tragedy of commons, and one aspect, one important property of tragedy of commons is that we have privatization of profit, but we have public distribution of any cost. So, let us go into more detail what is the tragedy of commons. This was first published in 1968 by Garrett Hardin, who was an American ecologist, and the phenomena that Garrett Hardin observed was basically that when you have a shared resource in which any given user reaps the full benefit of his or her personal use, while the losses are distributed amongst all users. What happens is that no one takes the ownership of maintaining that particular resource. So, what happens is that the more and more users derive profit, but the common property, no one takes the ownership of maintaining it and it gets to degradation. An example would be an use of public park that lot of users are using, they are coming and making it dirty, but no one takes the ownership of cleaning it up. The same happens with our environmental resources. So, this is what is called as tragedy of commons, is that we are exploiting the resources for our own benefit, but we are not maintaining the resources because it is a common pool resource. So, one example of tragedy of freedom in commons is that let us say we have a pasture land and we are a lot of different animal owners are using it. So, let us say a private owner or a owner of different herds buys one more cow and add to it, right. So, the person who is deriving the benefit would be the person who is owning the cow. So, the benefit would be that they have increased milk production, and it goes to the owner of the cow. Okay. But what happens is that because now you have added one more cow to the pasture land, the cost is that the pasture land will get more degraded. And the reason is that now we have more stress on the pasture land, which is the ecosystem, to maintain these herd of animals for their production. And the cost is actually shared by all the users. So now if we think about the sustainable design, there is no one actually talking about what is the limits or the capacity of this pasture land, so that they can limit the private owner to actually keep adding more and more cows. So if a person is making more profit and actually buying more and more cows without considering the limits on the pasture land will keep on degrading, and eventually no one will be able to sustain their animal herd. So this is a very common phenomena of tragedy of commons, because your profit is privatized, it is owned by one owner and they don't think about the common good, but the cost is shared by all the users. So what happens eventually is that there is degradation of the soil quality and pasture land, and eventually the system collapses and no one gets anything. Another same example is fisheries in ocean. So what happens is that when fishermen fish, they can keep on extracting more and more. So let's say a fisherman gets a new fleet of boat, they will get the benefit of more fish production. And the benefit is going to the owner of the new fleet. But the cost will be that if you are overfishing an area, the fishes don't get time to regenerate fast enough. So what happens is that decline in overall fish population. And the cost is shared by all fishermen. So now you see, a person or a fisherman can keep adding more and more fleet without thinking about the ecological sustainability of that fisheries system, and keep overfishing some region. Eventually what will happen is that none of the fishermen will find the supply of the fishes, because they have overfished and they have actually declined the fisheries population. So this is another example of tragedy of commons, that without thinking about the cost to all the users or all the users who have the access to the common pool of resources, we are leading to the decline of the ecological system. So when we think about the basic property that is leading to tragedy of commons, the first thing we think about is privatization of profit, and the second thing is public sharing of cost. So whenever we are thinking of sustainable systems, we need to definitely think about who is getting the profit out of that system and what are the costs that are there because of the use of that system, that is a negative externality and that is being shared by lot of different people. This picture is actually showing an overcrowded road, which we know that is an issue in a lot of metropolitan cities in India, is that everyone thinks that if everyone could just take a public transport, then they could reach home earlier. But no one wants to actually give up the profit of riding in their own cars. So this is an example of privatization of profit, but negative externality to all the common users, and when everyone starts doing that, the system gets in a landlocked area and no one gets the benefit. So, one of the very important aspect of designing sustainable systems is to think about these negative externalities and internalizing these into our decision making and design systems. So, how do we overcome externality? So, Hardin suggested that we can actually do a strict legislation, but there is of course no perfect solution because no one likes that top down approach. So, no one enjoys taxes is what Hardin wrote. There are other strategies that we can do, which is community norms, which is more of a social aspect of sustainable systems design, where communities come together and set rules and regulations. But there is also hard cap, which is now one of the aspects that people are thinking about controlling the carbon pollution in terms of carbon taxes. But there is of course no perfect solution, and so far this complex challenge has not been solved, but now due to the overspread degradation of ecosystem, we are seeing widespread coordination between different nations and countries that are actually coming together, and one example is the Paris Agreement that India is also a big part of. So, when people started thinking about environment and business, which is the economics part, then they started thinking about that from environmental management we need to move to environmental strategy. So, when we think about pollution as a challenge, when we think about pollution as something that we really need to just deal with, we will not think about strategic decision making where we can be innovative in finding the designs that can be an opportunity to win stakeholders. So, now what the business world is thinking of is changing from win-lose to win-win perspective. So, what is this win-lose and win-win perspective? Here is an example of the win-lose scenario. So, of course, this is at the interaction of the economic and the environmental pillar of sustainability. So, on the x-axis we have the economic growth, and on the y-axis we have environmental protection, and you can see that the option B is where we are talking about very high economic growth, and it is showing very low on the environmental protection axis, which means that if we are going to increase our economic growth fast, we might not be able to protect our environment. Similarly, if we are high on our environmental protection, we will be low on the economic growth, which is certainly not desirable from the sustainability or the economic paradigm sustainability. There is something in the middle way where we compromise a little bit both on the economic growth and environmental protection. Of course, this viewpoint is saying that if we need to increase economic growth, we must give up on environmental protection. But eventually that would lead to the collapse of our ecological systems, and we will not be able to meet the demands of future generations, and that contradicts the basic definition of sustainability. So, this is the win-lose scenario where we think that environment and economy are at conflict with each other. However, there is other viewpoint, which is the win-win perspective. In the win-win perspective, we are also talking about economic growth and environmental protection. So, you see that the X option is where we have low economic growth and also low economic environmental protection. But we might have an Y option where we will see a high economic growth and also high environmental protection. So, such opportunities are rare, but when such opportunities exist, it really helps to bring together the environmental and economic pillars of sustainability. An example of such opportunity in today's world is renewable energy. So, the options in renewable energy like wind and solar, they present an opportunity to reduce greenhouse gas emissions in our environment, which helps us on the environmental protection aspect. But solar and wind are also very opportune technologies to provide employment to local population, thus leading to economic growth in that region. So, they are helping to reduce emissions, but also providing economic growth opportunities. Therefore, there is a huge investment in renewable energy technologies worldwide that is helping us meet both the environmental and economic sustainability challenges. The last one is environmental strategy. So, in the environmental strategy, we have two aspects. One is the economic growth and environmental protection. So, here instead of just thinking that we have a win-lose perspective where if we go high on environmental protection, then we have a low economic growth opportunity. So, this combines the win-win and win-lose perspective. So, this is where we have the win-win scenario, which is we shift from point A to D, where we have both increase in economic growth and increase in environmental protection. However, once we are reaching this new equilibrium, we can then move along this line to think about where we are going to optimize to reach the environmental protection and economic growth balance. So, this is where we have an strategic decision making. An example is that we are shifting from carbon based economy to the from the fossil based economy to the renewable bio based economy. And the reason is that there is a win-win scenario, because when we shift from, let's say, fossil based plastic to bioplastics, we are jumping from the system A to system D by completely transforming the technology. So, we have an economic growth because we are setting up new plants, and we are also protecting environment by not exploiting most of the fossil carbon. But when we reach there, then we have to optimize those plants to actually lead to economic profitability while also reducing environmental challenges. So, that is a very important new example of environmental strategy, which is shift from bio-based economy is something like waste to value added. Going forward, this technology will be a very key technology in meeting both environmental and economic sustainability challenges. The second reason which we think about when we are thinking about sustainable systems design and we fail is the reductionist versus holistic systems view. So, this is a fable, and I think a lot of people know about it. Is when there were 10 different people who were looking at different parts of the elephant, and everyone had their own perspective. So, one person hold the tail and says it's a rope. Then there is another person who looks at the leg of the elephant and says it's a tree. Someone holds their trunk and they say it's a snake, and they can hold their horn and they say it's a spear. But you will see that no one knows that it's an elephant, and that is exactly the challenge with sustainable systems design. When different engineers, economists, social policy makers are working, they are looking at different aspects of the same system. And since they are not working together, they do not have the whole view of that particular technology and how it interacts. They do not design it thinking of it as an elephant, but only as one part. So, when you design it separately and put it together, it does not function the way you would want it for meeting the sustainability goal. And hence, we need to move away from this reductionist view of design to more holistic view of design. So, the challenge is that the reductionism is still there, and the reason is because the whole system and interconnections are not included. It's not easy because when you think about the networks, the wide web is a network. Similarly, all the production systems are embedded in a network production system. We do not have visibility, and how do we take account of all these interconnections? The microscopic view of science, mostly looking at very fundamental, which is very important for making all the new innovations and new technologies. However, when they are put together, they behave differently. So, when we cannot connect the microscopic with the macroscopic view, we lose that ability to design systems for overall sustainability. So, what happens because of this is that our decisions are short-sighted. We have wide scale degradation. We do not, when a system is designed and already in place, we cannot change it for its interaction with other systems. So, and as a designer, we say that we were not able to see the change. So, and the most important thing is that we need to overcome this reductionism and take a systems approach. And this course is particularly focused on teaching you the tools and techniques that we need to move away from this reductionist view of design towards a holistic view of design. So, we will focus on life cycle analysis, which is a systems view of looking at all the systems together, and from the start to the end. We will look at the footprint methods. We will talk about carbon footprint, nitrogen footprint, water footprint, and also ecological footprint to see how the systems that we are designing are affecting different aspects of important measures for maintaining Earth sustainability. And then we will talk about industrial ecology, which is looking at how different industries interact and what can we learn from nature for sustainable designs of these technologies. In summary, the challenges we face is that our markets ignore the environmental cost in design. Environmental management that has been there are mostly end of pipe solution, and we need to move away from more environmental management to strategy, and we need to move away from reductionism and adopt the systems view for sustainable systems design. So, in our next lecture, we will get started with some of these introduction to the techniques for sustainable systems design. Before we get there, I will like to highlight the engineer's role in sustainable system design. We want to design systems to ensure that we meet the demands, which is the first criteria for sustainable systems design. We reduce or slow down degradation, which means that we want to incorporate the ecological or environmental paradigm of sustainability in our systems design. We use the resources wisely, which is both the economic and the ecological sustainability paradigm. We make the system robust, which is another aspect of sustainability which is adaptable to forthcoming changes. And last, we integrate the social, ecological and economic goals in design analysis and take a holistic approach. With that, we will end the lecture today and we will move to the second lecture.